Thank you. So today we'll talk a bit about math and web scraping, and my intention is to show you that school level math is useful for programming, and that's it. Okay. I will talk about a bit how we at my company solved the problem of scraping Google Maps pagination without using headless browser, and how we reverse engineered JavaScript, and how we used mathematical formulas in order to do that. So I will talk about that button that scrolls to the right, I mean loads more data from Google Maps. So when Google making the request, the URL looks like this. And let me, okay. So here there is a large array of protobuf data that is encoded into string using exclamation marks and other specific letters, like, for example, here it's a 4M, which means there is a nested hash that have several items, and for example 3M also tells that it's an instant nested array. It's a hash that has items. 2I means it's an integer, and there are other data types. So the challenge is to reverse engineer that stuff without using headless browser. And so the plan is to understand how that PB string query parameter is constructed. Then we want to generate that string. And the next step is to actually fetch the data and extract data from that. And that's another challenge. I won't talk about extracting data because it's a whole lot of other things to consider, because Google returns deeply nested array of hashes and arrays, and that's complicated. So decoding URL parameter. Google Maps URL contains a PB parameter that contains, as I said, string encoded protobuf. And protobuf is a data format from Google. It's like we found on the internet that there are several ways to extract the data, and even kind of official guide from Google itself on how to reverse engineer and how to debug that protobuf models without knowing actual structures. And what we like in the result, what we need to do is to find out how to pass latitude, longitude, altitude in feet, and pagination offset into that URL here. Here and also Google have this is an example of what kind of data Google returns when I talk about nested arrays, like array of arrays, some integer strings. So basically it's a closure compiled and obfuscated JavaScript that's hard to understand, hard to parse, hard to guess, hard to do anything with that. And after reading source code of Google Maps JavaScript, like trying to understand what's inside and stuff like that, we found out that there are several places where we can pass our altitude, longitude, latitude, longitude, and also query, and somewhere inside there is also a pagination, no, not somewhere also there is a pagination offset. Okay. And also the challenge, so we didn't want to add extra parameters like longitude, latitude, and altitude to our API. We want to also to allow our customers to copy like parameters from Google Maps, like go to Google Maps, copy the URL itself and paste parameters just from it to our API, and everything else should be done on our side. And it also turned out that like in the URL, there is a parameter like googlemaps.com/search/query/add like float, comma float, then so latitude, comma longitude, comma zoom level z, and so this is a LL parameter. So, and also I will explain. Like, I understand that this is completely not clear what I'm talking about, but I will explain it later, like during the talk. So we read several like pages of code of Google Maps and combined multiple formulas from it, and found that this is a formula to calculate, this is a formula that Google uses to calculate zoom level based on latitude and altitude in feet. So Google uses Earth radius in meters. Also, there is a tile size, like Google Maps uses tiles 256 pixels per 256 pixels square tiles for its maps, and also it uses pixel screen height for its formula. And so this is how it renders, and this is how it works on the front-end side. But in order to make an actual request, we needed to reverse the formula. So I took that formula, went to Wolfram Alpha. Like this is how it looks like this is how the formula looks in the Google Maps JavaScript code. And I wanted to, given the altitude, longitude, I wanted to get that z parameter in order to make an actual request to Google Maps. So I went to Wolfram Alpha. Wolfram Alpha is a tool to do interesting stuff with mathematics. So I basically pasted that formula, and I inputted this formula into Wolfram Alpha and clicked like something like simplify it or something, and it did pretty good job like simplifying that one, the top one, to the bottom one. And then I read several books, like tried to remind like middle school logarithmic equations, and in order to how to reverse that. So we have a formula, like we want to do the reverse in altitude, and I want to, like, I went to several steps in order to like reverse the formula. So sorry, I did it in Ukrainian, so I don't know how to speak that stuff in English, sorry. But basically, after several iterations of reading books and trying to figure out how it works, like I came up with that formula, and here is me. And here is the Ruby code for all of that magic. So we have Earth radius in meters, tile size, screen pixels height, radius pixel height, and so in order to get an altitude for the zoom level and altitude from the LL parameter from Google Maps URL, we need to simply do all of that. Like pixel height multiplied for cosinus of latitude multiplied by p divided by 180 and other stuff. And also and here is the stuff for that I told about LL parameter. So LL is the parameter that equals starts with @ sign, then float number, comma, float number, comma, zoom level z. And here is and that's one of the parts that I really love with Ruby, that I can do multi-line regular expression with the comments. And this regular expression still works to 3 years later. And so basically, here how we extracted parameters from that LL parameter. Yeah, basically it was it. So putting all together, here is how we extract latitude, longitude, latitude, float number, longitude, float number, zoom level, integer. So we extract it, then we defining several constants that we found on Google in Google Maps JavaScript code. And then here is the function that generates URL for Google Maps to fetch the data from the specific page, given the LL parameter, and start is a pagination offset. So we extract parameters from using regular expression here on the first line. Then we combine, we put into the placeholders altitude, longitude, latitude, pagination offset. Somewhere here should be also search query. Maybe it's another part. Probably it's another part. And yeah, and that's it. And so it was super hard, and you might wonder why bother and why don't we use browser automation. And while it's super easy to use browser automation for all of that stuff, and people right now, in the recent years, really love Puppeteer, Playwright, and stuff like that, for us it's more fun to understand how it actually worked. And it's also much simpler to maintain. It still works 3 years later, we don't touch it. We only extract new data and the pagination works. And it wouldn't work with Puppeteer because Google adds more stuff. We would need to wait for extra data. And if you like working on that, we would like you to join us. That's it.
But it works 3 years later. What?
There are other websites.
Could you say more why you do this? You're trying to get information from Google Maps?
Yeah.
Right? So you have from grocery to grocery and fetch it, or?
Yeah, so we basically scrape Google and other search engines, and Google Maps is one of them. For example, for local SEO, when people want to track their ratings or track their, monitor their user reviews or do competitor research on Google Maps, you can use our API in order to find top results, paginate, stuff like that, also find everything.
Thanks.
Thank you for the question.